So once we have found the area of the wall, we then need to calculate the number of paint cans used to paint the wall. So what we do is we take this number and we say that up here it told us that one paint can cover an area of 5 meters squared, which means that one can covers 5 meters squared. Okay, so we're going to multiply that by 30.98 meters squared. So if you were thinking about how to do this ahead of time, you might have been thinking, wait, I think I need to divide them. And you would be totally right. The thing here is that what I'm trying to do is trying to convert my units of measurements into cans. So if you remember conversion rates at all, this is kind of following along the same thing. Notice that dividing by meters squared is going to cancel out with these meters squared, and the only unit of measurement left is going to be a can, which is exactly what we want. Okay, so 1 can per 5 meters. If you hear the word per, it's a rate, which means it's a fraction of some kind. So what we need to do is we need to take 30.98 and divide it by 5. What we get is 6.19 paint cans. And while we are learning about how to round, this would technically round down if we're talking about rounding it to the nearest whole number, because we can't buy a fraction of a paint can. However, in this case, if we round down, we wouldn't have enough paint in order to finish covering the wall. There'd be 0.19 area left that we wouldn't be able to cover. So we actually have to, in some application circumstances, round up, right? In order to cover everything that we need to cover, we need to round up. So we need to get 7 paint cans. All right. Find the cost of painting the wall reported to a suitable level of accuracy. So it says that each paint can costs $5.69. So if we're buying 7 cans, one can is $5.69. So notice again, we are canceling out can as a unit of measurement and being left with dollars. If we multiply those together, we get 39.83. And realize that with most currencies, 2 decimal places is the suitable level of accuracy. So if we're talking about money, we're more than likely going to be rounding it to 2 decimal places. Okay, so this front page is just all about rounding and significant figures and everything that has to do with that. And now we have to talk about bounds. Why do we have to talk about bounds? Because when we round numbers, we are no longer accurate. And so sometimes in our mathematics, we need to figure out, okay, well, we're no longer exact, right? Rounding 3.1415926, in other words, pi, right? If we round that number to anything, if we write it down as a number, we've automatically eliminated it as the actual number, right? The only exact way to write that number is by writing this symbol pi, okay? So if we round it at all, it's no longer the exact. And so we write these bounds to say, well, the exact number, not the rounded one, but the exact one is somewhere within this range. So what we're doing is we are creating a range. It's the idea. So if we rounded it to 3.14, then we said, okay, well, technically this is a nice approximation of that number, but the real number actually lives between 2 other numbers. Now, we'll start with the lower one, 3.135, okay? The idea here is that if you are at 3.135, so we'll do a little thought bubble to the side, 3.135, if you rounded it to 2 decimal places, would become 3.14. So this number is within the neighborhood that would round to this number, right? This guy would round, so we include it. And then anything above this would also round to this number if we're talking about this number of decimal places. However, on the other side of the bound, we have something that would not round to this number, which is why it's strictly less than, okay? This number, 3.145, would round to 3.15. So we are not within the neighborhood to round to this number. However, if we had 3.14499999, that is the number that's just below this number on the number line. That would then round to 3.14. So that is included in this neighborhood. And so that's the general idea of bounds. So we have a formula for bounds. It deals with P, and P is what we call your level of precision. Okay, so your level of precision is basically where you round to. So for example, if your level of precision is to the 10th place, that is to the first decimal place, your P is not the digit that's actually in the 10th place, but instead it is 0.1. It's 1 in that place that you rounded to. I rounded to the 10th place, and so now I put a 1 there. I'll give you a different example. If we round to the 100th place, which is your second decimal, then your P is 0.0. This is the 100th place, and we would put a 1. So it's always 1 in that place that we rounded to, but we have to make sure that we're taking into consideration where we rounded to. So to the tens place, your tens place is here, so we put a 1 there. Your hundreds place, your P would be 100, okay? So what you do is you have your number that you rounded, and it's always going to be less than or equal to, and then strictly less than. And then you have a minimum on this side, and you have a maximum on this side. Again, creating that range of numbers in which if you had a number anywhere within this range, it would round to that middle number. How you find this minimum number is that you take the x value and you subtract P divided by 2. So going back up to here, 3.14, we rounded to this spot. So your P would be 0.01. Your P over 2 would be 0.005. If that process stressed you out, don't worry about it. Get your calculator. Use it every time. It's no big deal. So then you take this number and you subtract it. Use your calculator, subtract it to get this number. Your maximum is when you take this P over 2 and you add it to x. And that's the idea. So let's go through an example. So let's, for example, say that we rounded a number to 48.2. So we rounded it maybe to 3 significant figures, or maybe we rounded it to the 10th place or to 1 decimal place. So if we rounded it to this spot, your P would then be 0.1. So notice it's to the same spot, it's just 1. Then your P over 2 would be 0.05. So I then take the number that I rounded and create the skeleton of this situation. So I put in the bounds, the inequalities there already. And then I just say, okay, I can take my calculator, or I can do it in my head if I can do it in my head. And I add 0.05. And I subtract 0.05. And that gives me my bounds. And that's it. When it's asking for bounds, that's all you have to do. Sometimes, here is a hint or a trick or something. When I round it and I'm trying to think about the bounds, I always add in an extra 0 and then just focus on that number. So I add in an extra 0 to where I rounded it to, and I think about that. And I say, okay, I need to add and subtract 5 to 20. So I do 48.25 and then 48.15. And that's how I do it in my head super quickly. So if this shortcut works for you by adding on a 0 to wherever you did it, so up here it would be adding on a 0 and thinking about it as 40 and say, okay, I write everything up to this point and then do 45, and then everything up to that point and then do 35. 45, 40, 35. That's how I do it as a shortcut in my head. So let's practice. We're going to find the bound for each of the following measurements given the level of precision. So we have force, which is newtons, and it says that the force is 14 newtons, and it says it's rounded to the nearest newton. This can be confusing. If it's rounded to the nearest newton, it means it's rounding to the nearest whole number, which means we rounded to the ones place. If we rounded to the ones place, then our P is 1, which means our P over 2 is 0.5. Just divide it by 2. So then we take 14 and create the skeleton of this problem, and we add 0.5 and we subtract 0.5. And you're done. Next one, time, 5.309 seconds, rounded to the nearest thousandth of a second. Tenths, hundredths, thousandths. So we rounded it to this number right here. So our P is going to be 0.001, which means our P over 2 is going to be, use your calculator if you need to. There is no shame in using your calculator. So then we take this number and we add it and subtract it to that number, which I'm not even using my calculator. I'm only following the process for those of you that are following this process, because all I'm going to do is I'm going to think of that as a 90 and do 5.3095 and 5.3085. And you're done.